Okay, let's make our own little cheesy checkpoint here. That's the player. Oh, very nicely commented from Zert. Thank you, Zert. So I think I need to go here. Zert! Oh no! Dare to use cheese in my game? Oh no! Long berry! Oh my goodness!
I think it's not intended, though it's a bug, right? Because I think the counter is reset when you touch the box. Haha. Okay, here. Oh no! What? No! Oh! Oh my god! Oh my god! So I'm scared. I think it's just, oh my god. Try to use magic in my game. Of course.
Hello there! So what you just saw are two of my favorite clips from two lovely Game Builder Garage streamers, VideoDojo and jJaeStudio. And as you saw in those clips, both of them tried to cheat in one of my games. However, they were met with quite a surprise when I showed that I knew exactly what they were going to do, and somehow able to detect it within the game itself. So if you ever wondered how I did that, well, in this video, I'll be discussing the exact glitch which makes it possible for you to detect whenever a player enters the programming screen or retries the game. I'll also go into a few more other applications of the same glitch, such as counting the number of retries the game has done, even without using a swap node on. Now let's begin. So this glitch hinges on the location sensor. So something interesting about the location sensor, if you didn't know, the location sensor outputs its value in the programming screen during the first 2 frames of a game. So let me try to break that down. So for example, you have a number object here, and just make that here. So, well, if you take a normal location sensor, and like, for example, here, location sensor says the world, version 0.4, send it to here, you'll see that it says 0.4 as expected. But what will happen if we have a object here, make it not movable, and connect the sensor here? So intuition would tell you that, well, the location sensor is connected to the box, so the location sensor should send the value, or should give out the location of the box. So let's try that out. And see here, it shows 0, which is the position of the box. But if we look closely, well, right now, the location sensor's X position is at 0.8. And if we look really closely here, let's see what happens during the start of the game. Did you see that? Let me just keep resetting it so that you can see it. So you can see here that actually, at the very start of the game, the value that's being sent to this number object is not 0. It's 0.8. And yeah, it's actually sending whatever the location sensor is outputting while it's in the programming screen. So for example, if I move it here, now it's negative 1.1. This is at the world, so negative 1.1. And if we load it up, you'll see that it's negative 1.1 at the start as well. So now that's very interesting. What can we do with that? Well, with the world setting, not much, or that's something you need to keep in mind if ever you're using a system that uses location sensors. Like, just keep in mind that during the start of the game, the position of your location sensor in the programming screen actually matters. If like sending it to control something's movement, maybe you'll be surprised that, oh, it suddenly jumps up somewhere during the start of the game. And that's because it outputs the value that it has in the programming screen instead of where it should be during the first 2 frames of the game. So it is for the world setting. Now, what would happen if we change it to initial position? Well, let's see. If connect it here, let's say move it here, we'll see that the location sensor, even if it's set to initial position, or since it's set to initial position, it's assuming that its initial position is 0. So since it's at position 0.8, it sends out a 0.8. Let's see that. You see there, 0.8 just flashed there. But now, what happens if we move this object somewhere to the right? So for example, here, or let's move to -1. What would happen then? Well, okay, right here is saying 0.8. What will it show? There it showed 0.8, but then now, look here. For some reason, it's now showing 1.8. And we go in again. We can see that the 1.8 flashes there at the very start. So what's happening there? So actually, a weird quirk that the location sensor set to initial position has is that during the very first time a game is loaded, the location sensor assumes that its initial position is 0. So that's what we saw earlier. Or actually, we could just grab a yeah, we can just grab this new sensor. So during the first iteration that the game loads the programming screen, it assumes that the initial position is 0. So that's why if we like move this around, like move this to x is equal to 0.75, it will show 0.75. But after it loads the game once, it will try to update the real initial position of all the location sensors set to initial position. So it will basically look at all of, or it will basically generate the game, look at the first frame of the game, and see what the actual initial position of the sensor is. So in this example here, since we already loaded the game once, so the position of this box is -1. After that first time that we played the game, the location sensor's initial position got updated to -1. That's why if we move it here, it becomes 0. And now when we move it to 0, 0, now it becomes 1, since its like position is 1 meter to the right of its quote-unquote initial position. That's why, yeah, we see that when we load the game, here, it'll show a 1 now. And if we move it like to x is equal to 1, it will now flash a 2. Because once again, its initial position is -1 and its position is 1, so 1 minus -1, that's 2. And what if we move the box even further? For example, -2. Now what should the value of the location sensor be? Or let's say let's put it at equal to 0. So right now, the location sensor thinks its initial position is -1, so at 0 it shows 1. And when we can expect that whenever we load the game again, it will show 1 during the first 2 frames, and then become 0 again once it updates to this box. But the next time we look at the programming screen, what will be the output of this location sensor? Well, since we load the game again, the initial position of the location sensor will be updated to its initial position in the next time we load the game. So next time we load the game, the location sensor will be now here at x is equal to -2. So if the new initial position of the location sensor will be -2, then if right now it's at 0, let's see here. There we see 1, and we come back to the programming screen, it's now 2, because the initial position, its initial position is now -2. So that's why the x here is now 2. So that's the gist of the weird mechanics of the location sensor. Now, how do we make use of this to determine whether or not someone goes into the programming screen? Well, I mentioned earlier that the first time that the game is loaded, the location sensor assumes that its initial position is 0. So, example, let's see here. Example, let's set its position to 1. So when we leave the game, well, since the first time that a game is loaded, its initial position is 0, if its position in the programming screen is at 1, then during the start of the game, it will output 1. You see that there? You can see there, it flashed 1 for a second, or a brief second. But then, the next time, or now, since the game was already loaded once, the location sensor updated its initial position to its new initial position, which is 1. So now, since the initial position is 1, the value that it's sending out is now 0, since its initial position is now the same as its current position. And if we load the game again, we can see that the number object stays at 0. So basically, what we have here is a system where the first time we open the game, a 1 flashes here. And every time, and every other time that we load the game again, without leaving the game, it will be 0. So it's the same as, it's not just locked to just going to the programming screen, it's also like anytime the game is loaded again. So like for example, here is the first time, and if we reset again, it shows 0 as well. So it's not just whenever you go in the programming screen and come back, it also updates whenever you reset the game. And that's also the same if you retry the game. But actually, it's not, whenever you swap a game, it actually resets it. So whenever you swap a game, the initial positions of all location sensors are actually reset back to 0. So if we try that, so let's just put a random keywords here and have it swap to itself. Let's add a button here. So let's see, if we come into the game fresh, we will see that it showed the 1 at the start. And when we try to swap the game to itself, it will show the 1 again. Whenever I swap to itself, it will keep showing the 1. But when I reset or retry, it becomes 0. And when I come to the program screen, it becomes 0. And it's the same with a retry node on. So let's just showcase that. Let's connect this to B. Now, the first time we enter the game, it shows the 1. And then when we retry, it's 0. This is me retrying, and then next I'm gonna try to swap. It shows the 1. So now you basically have a system that reacts differently for the first time that you enter the game compared to when you come back to the game after going to the programming screen or retrying the game. So how do we actually make use of that signal during the first 2 frames. So actually, the developers kind of planned for this already, because like you might be thinking, well, what if we just attach a counter to it and then send that to a number object? So if you're saying that like the output of this is becomes 1 during the first few frames of the game, well, during those first few frames, that should increase the value of the counter. And then we can see the value of the first few frames here in this second number object. So let's try to see what happens. So here, you can see that, well, this number object directly connected to the location sensor worked, but for some reason, number object here didn't work. So why is that? That's actually because the most storage node, like for example, counters, flags, randoms, and a lot of other nodons, they only start working starting from the 3rd frame. So since the output of the location sensor is only weird during the first 2 frames, we actually, if we're connecting this to like anything that has a counter, flag, or random, basically anything that's gonna remember anything that happened during the first 2 frames, it actually won't matter, since they don't work during the first 2 frames. They only work starting the 3rd frame. So the developers kind of have a plan for this already to prevent this from doing anything weird. However, there's actually a way for us to bypass that. So here, well, here I'm going to make a block of code which makes use of a mechanic called subframes. So if you don't know how subframes work, don't worry about it. For this video, you don't need to really know how this block of code works. I'll just tell you what it does. I'll show you how to make it. You don't need to know how it works. You just need to copy this, and yeah, don't worry about doing anything else in the middle. I'll just show you the input, the output, and what it does. So what this does is basically it just saves whatever input it gets during the first frame of the game. So let me show you. So here, let's just make the example with the location sensor set to world. Here we have a location sensor set to world, position at 1 in the programming screen. So a location sensor like this will output its position in the programming screen during the first 2 frames of the game. And then on the 3rd frame, it's gonna correct itself to its actual position in the game. So here, this signal should output a 1 during the first 2 frames. Now let me just put up a bunch of number objects here. So this system actually has 2 outputs. So yeah, so this input, this first output is basically the number that was saved. So this is a number that is on this input during the first frame of the game, while this output will be whatever this output is, but inverted. So this is basically an extra thing to add more shavings, to shave more nodons. Let me just show you. So here's the location sensor. It's set to 1. And you can see here that, yeah, in the actual game, it actually is able to save the value 1 that is used in this video. So let me show you an example of, I show you that it doesn't work if you do it normally. Like for example, if we have a counter, connect this here. And let's just have the raw value on the bottom one. So if you look here, this one flashes 1 for 1 frame, or for 2 frames. This is a counter output. So since it doesn't work during the first 2 frames, it's 0. But here we have our special block of code, which is able to see and save that value at the first frame and also give an inverted output. So let me reset again and see here. And it since the sensor is always positioned at x equal to 1 on the programming screen, every time we reset the game, it will show a 1 here. So now how do we use this to basically detect when a person resets the game or goes into the programming screen? Well, we can go back to our example with the initial position. Here with the initial position setup, you have a location sensor at position 1. And as I mentioned earlier, during the first time the game is played, this sensor will output its position during the first 2 frames. And then after that, it will update its initial position and it will keep outputting 0. So basically, if this works correctly, you have something that when we open the game for the first time, you will see that this is able to detect a 1. But when we go into the programming screen and come back, it's now 0. And whenever we reset, it's still 0. If we retry, it's still 0. If we swap here, it will reset to 1. And if we retry after that, it'll go back to 0. So now we have the first part of detecting whenever a person goes into the programming screen. So basically, we just need to detect if the value stored here is 1 or 0. So what we can do is, well, we can just get a NOT. Let's see what the output of the NOT will be. If we enter the game for the first time, it's going to show 0. Then the next time, it's going to show 1. So yeah, that's basically it. So now we have the output of this NOT is 0 during the first time someone enters their game, and then it becomes 1 whenever they go into the program screen and come back out again, or whenever they reset. Let me show that again. So if we swap to it, it resets to 0. And if we retry, it becomes 1. Or if we swap to it, 0, go into program screen, leave, becomes 1. So that's basically it. That's the first part of this tutorial. And for this location sensor, it doesn't need to be 1, because here we're just detecting if the value here is not 0. So like for example, even if like you put it here, say 0.6, during the first time that we enter the game, this will be 0.6, and the NOT will detect, oh, it's not 0, so it's 0, and when we come back, it's 0, it'll become 1. It doesn't really matter. This the value of this just needs to be anything besides 0. As a quick aside, if you watch my invisible thumbnails tutorial, this circuit that I showed there for a brief time now makes sense. So let's remove this location sensor for now. So in this system, well, the on start activates on the 3rd frame. This is connected to the flag. The flag activates starting the 4th frame. So basically here, this NOT has a input of 1 starting from the 3rd frame until the end of the game. But for the first 2 frames, these inputs are 0. So for the first 2 frames, this NOT will output a value, and that will show this texture here. That's it. Let's imagine that's our thumbnail. Now we have a thing that only shows up for the first 2 frames of the game. Now, what happens if we connect a location sensor set to initial position? Well, as we discussed earlier, if the sensor is placed at a position that's not 0, this thing will output its position for the first 2 frames of the game the first time the game is opened. So the first time the game is opened, during the first 2 frames, this is on. On the 3rd frame, this is on. And on the 4th frame onwards, this is on. So basically, this NOT will never be on. And therefore, this texture will never turn on during the first time you open the game. But the second time you open the game, the location sensor's initial position is now initialized to whatever position it has, and then it will now start outputting 0. So now, during the second and future times you open the game or retry the game, during the first 2 frames, this NOT turns on, and on the 3rd frame onwards, it will turn off. So the thumbnail is not generated during the first time you open it. It's generated on the second time you open it. So that's why the first time we open it and open the game, we don't see the thumbnail at all because this location sensor sent out a signal for the first 2 frames. But every other time that we open the game, we can see that the texture shows up there, and that's also what the game uses to make the thumbnail. So using this trick, we can make a system that doesn't show the thumbnail during the first time you open it and only shows it from the second time onwards. Now, what else can we do with this weird quirk of the location sensor? Well, what if I took let me just make the setup first. So this is just a box on top of a box connected through a FreeSide connector. So here, if I do nothing, the box is just on top of the box. If I put a constant, notice that the box here is offset by 1 meter to the right on the x direction, and it's already there during the very start of the game. So even at the first frame of the game, it's already calculated that the position of this box should be 1 meter to the right here, based on the input of the FreeSider. So if we connect a location sensor here, and for example, let's set its initial position to 2. So what we learned from earlier, so if we forgot, this just saves the value set here during the first frame. So you will see the value of the first frame here for some object. So the first time we enter, you will see 2 because our location sensor was at x is equal to 2. But now, the next time that we go, we will see that the location sensor is now outputting 1. And that's because the location sensor sets its initial position to whatever its position is during the first frame whenever the game is loaded. So in this case, since the game loaded with this box at x is equal to 1, the initial position, so see here the box is basically here, the initial position of the location sensor now becomes 1. And we can see here that, yeah, it says 0 here, and if we move it to the right, it gets bigger. Okay, so that's fine. Now what if we do something weird? Like, what if we connect this value back to this x value? What do you think will happen? Well, the first time we enter the game, the sensor will output 0. So basically, since it's outputting 0, the input to this three-sider is still 1. So at 1 plus 0, the box moves at x equal to 1, like normal. Now here, see what happens. Since the location sensor is connected to this box, now the initial position that it saved is 1. So like in the last time we opened the game, this was here at x equal to 1. So now it thinks its initial position is here, which is 1. Okay. Let's put it back. Let's put it back where they were. Now, wait a minute. If the initial position of the location sensor is now 1, but since its position in the programming screen is now 0, that means its output will now be negative 1, because it thinks it's supposed to be here. It thinks it's supposed to be here, and now it thinks, oh, I'm 1 meter away to the left of where I'm supposed to be. So that's why it outputs negative 1. But since we're sending that number back to this three-sider, now the value sent to the three-sider during the first frame of the game will now be 1 plus negative 1, which is 0. And if we look into the game, it will be 0. But now, since it's 0, well, the initial position of the sensor is now 0 again. So the next time you load the game, the outside here will be 0 plus 1, which is 1. And now, the sensor should be outputting negative 1. So now it's going to be sending 1 plus negative 1, which is 0. And then 1. And 0. And then 1. So now we have this very interesting behavior where every other time we reset the game, the position of this block is different. That's very interesting on its own. But we can do even better than this. What if I send here this negative value? What would happen then? So let me show the negative value here. Well, the first time we load the game, it will output 0. But now, we are sending, well, now its initial position is 1. So since it's at 0, its offset is now negative 1. But since we're getting the negatives now, well, this is negative 1, but we're sending the inverse of that, which is 1 instead. So now, you'll see that the next position of the three-sider is now 2. So the next time we load the game, this box will now be at x is equal to 2. And now since it started at 2, the offset of this one is now negative 2. So now we're going to see here 1 plus 2. Now it's 3. And then next time it's 4. And then it's 5. And so on and so forth. You can see the box just keeps moving right by 1 more and more each time. So basically now, what's happening here is since the location sensor, or the farther this box moves to the right, the larger the value, the more negative, or the larger the negative value this location sensor outputs. So whenever this moves to the right, this gets bigger, which pushes this even more to the right, which gets bigger, which pushes even more to the right, and this gets bigger, and this goes on an infinite loop of this number, just keep on getting bigger and bigger to no end. So now, you basically have, without using a swap node on, a way to count the number of times the player has entered the programming screen or reset the game. So we can just look at this bottom value here. So like the first time we enter the game, it's 0. The first time we try, it becomes 1, and then 2, then 3, and like if we go in the program screen, and 4, and 5, and so on. So now we have a system where even if the player tries to retry the game, or they go into the program screen, you can count. You can still remember how many times they've done it. So it's not actually true that the retry, whenever you retry a game, everything gets reset. Using this kind of system, we can basically still count how many times the player does that. So yeah, this is basically a system that counts how many times the player goes into the program screen or retries. Like if you want to shave even more, you can just you reuse the same constant, put it here. And there, that's the entire system. So in this case, we just need to make sure that this system is placed at x is equal to 0, because this will send out different values if it's not set to x equal to 0. So if you want to do something more complicated where it counts from a different number, it counts like different values, you can tinker with the initial position of this or initial position of the sensor and it's constant. But if you just want to count the literal number of times that the game is retried, you can use this. And if ever you have this kind of system and you want to reset this count, you can just swap to itself and like that, and it will reset it back to 0. And yeah, it will still work. It'll just count back up from 0. So one last thing, there's actually a much simpler setup that we can do. However, it does have some drawbacks. But it's basically, you can just take this inverter node on, connect it to the location sensor, and send it directly to this freesizer. So we can look at the value that's being sent to this inverted node on, and let's see what happens. At the very start, it's 0. Then we come here and here, it becomes 1. Okay, looks the same as before, but when we go in here, we notice that, well, at the start of the game, it's 1. Then it slowly went and stopped at 0.5. And then if we read that again, it becomes, you see there it starts at 2 and then goes back to 1, then 3, then goes to 1.5, 4, and goes to 2. So what's happening here? Well, let's take this for example. So right now, the value that or the offset that is sending out is -5. So invert it, it becomes 5. So right now, at the start of the game, this whole system will try to move to x is equal to 6. Let me find that for a moment. Okay, there. So it starts here. However, when that happens, since we're not saving the first value of the location sensor anymore, well, this value is now 0. So now it will try to go back to 1. And it goes back to, if it tries to go back to 1, well, if it stays at x is equal to 1, that doesn't work either, because now that means the value that's being sent out by the location sensor is now different. So basically, it will average out between 6 and 1. So that's why the value that comes out is basically half of what we're seeing here. So yeah, what's being sent out at the start is 5, but it average out, it's like it tries to average out with 0, and then it basically gets halved. So if we want to use this kind of mechanism, we can just fix it by changing this number to 2. So if we do that, basically the movement of the location sensor will double. So start at 0. The movement is now doubled, so now it becomes -2 and 2. But since the final value eventually gets halved, it basically does what we wanted earlier, where every time we open the game, it increases by 1. Now, as you hear, one problem with this kind of setup is it takes a few frames for the number to stabilize at the correct one. So if you have a system that might break if this value changes rapidly at the start, you might not want to use this and use the previous setup earlier, because in the previous setup earlier, the value that's being sent here gets decided instantly, and you don't have to worry about it going over and like moving through a range of different numbers before it stabilizes at the right value. But if you just care about the final value of this at after a few frames after starting the game, this would be a much more efficient solution for this kind of thing. So yeah. Now, one last question you might have is, well, I have this thing that has some kind of memory across resets. Can I somehow use this to store certain parts of memory that I want to save? Like, for example, can I send a number to the freesider so that that value will be saved to the location sensor during the next time I reset the game, for example? But unfortunately, that won't really work, because the value of the location sensor, or the initial position of the location sensor, which all of this hinges on, is determined at the first frame of the game. So basically, once the game starts, the next value that will be shown here in the next restart has already been determined. Whatever you do during this instance of the game is not going to change anything with the value of the next time you reset the game. So unfortunately, you can't really do that. So for this type of setup, you can only really remember the number of times you reset. And yeah, perhaps like something you could do is, like, if you want to save a certain number, you could theoretically like tell the game to reset that number of times, and then like you'd basically have the number. But if it's a pretty big number, like it's gonna take a while to reset that many times until the numbers get to there. But theoretically, it's possible. But yeah, the main application that this type of system is only useful for is if you want to count the number of times a reset has happened or someone has gone into the programming screen. But yeah, that's basically it for this video. I hope you learned something, and yeah, see you in the next video.